It's terrible, and I don't like it. What I am going to do first is make a new generator, because I make the generator, I make this encoder generator object, and just to get my latent space figured out, but I don't really want to do that. What I want is just a brand new generator, which means I need a brand new GAN. Okay. And what I want to do, I want to just run this for like one epoch. Let it go. Oh, that's going to crash and burn, isn't it? And we're going to change these fit functions to train on batch instead. And this needs to go. There we go. And you can see this is terrible, all those zeros. Like the GAN part is just awful. I don't know why that is. It is a mystery to me. Like GAN's supposed to take in arbitrary data. Or no, the GAN, sorry. In the GAN mode, I want to trick the discriminator. In the discriminator mode, you're like, I want the discriminator to be correct. But that is not what is actually happening in this situation. Alright, let me just kill this. As you can see, same situation. GAN mode is always giving me garbage. Discriminator, you know, does a halfway decent job. Or it's way too good, I should say. So I want to see, am I just doing something wrong? Is the learning rate way too high or something? We're going to try out a bunch of diagnostics. First, I want to do train on batch. And I think this kind of thing will work. If I just do this. Does that work? Yeah, okay, cool. What does this return? There's a bunch of different numbers. And it's the same fake data, so I'm going to change all these fits into train on batch. Train on batch. First of all, be a little less messy on screen. And then, yes, I have here, you know, check against the validation data. Well, what validation data do I have, actually? That's a good question. I'm not 100% sure. It could be like gan.predict, right? Predict, yeah. And what data do we want to put in? I wonder, can I, if I do fit, can I put in like no data? And only do validation? That would be very interesting if I could do that. Just to like get all those same metrics without having to think about this too hard. Let me do that actually. Pretend here with some fake data. Unless, sorry, I didn't even see this. Does this have, yeah, it doesn't have any extra information for like, oh, show me this, show me that. Show me the other thing. So with fake data and fake out, right. Oh, that's start, stop. What is this nonsense? What? This is crazy. Like, the amount of data that I'm generating here and the way I'm doing this is clearly insane. Right, and I run the generator predict on all of the data. Like, what is start stop in this instance? Start stop. Length of fake data. 32. What? Alright, maybe that's explaining some part of my problem. That fake data is yay long. Look over here. What is M? M is this. Set M equals 0. The first batch. Whatever. You do this. 32. Okay. It's fine. Everything's fine. I will retract my statement here then. Normal MS for M comma S and U comma standard. Oh, that's for all the arrays. Right. Here we change the size to like n valid. I don't know. Which is how many are valid. We'll just do like 1024. Doesn't need to be all of them. Invalid. Perfect. fake data, and we also need our fake out, which is really just 1 minus fake out of up to invalid. Those are all the same. Right, fake out. All a bunch of zeros. What I want, actually, where is my real data? Or did I have one hot data here. That's what I need. I need the one hot data, and I need to use that on the discriminator. Okay, so actually I don't want to fit the GAN at all. I want to predict with the GAN. Yeah, exactly like I do here, in fact. Gen data equals this. And then I want to do this. And we'll say all data equals numpy dot concatenate. And we're going to put in fake data, comma. Oh, hang on here. I need to figure out how much data I have left here. V split equals 0.9, because I saved 10% of my data. V split for validation purposes. So, what I need I have to think about this. One hot data. That shape. Yeah, I just need the last 10%. Okay. So V start equals length equals V split times length of one hot data. And we'll turn this into an integer, and that's fine. Boom. Okay. So all our fake data, and so in fact, invalid should be defined here as length of one hot data from V start to the end. See how that works. Groovy. So I don't need to define it here at all. I will generate new random data every time, because why the heck not? But concatenate our fake data along with our one hot data V start to the end. That should be what I want, because fake data should have the right shape. It does not. What do I... Oh, the GAN takes... okay. No, not fake data, gen data. That's right. That's what goes there. Gen data looks all like this, which is like one hot encoded, but it looks like hot garbage, which is fine. That still looks fine. Okay, we concatenate that. No. And then we say all truth is equal to numpy dot. Say numpy dot zeros of 2 times invalid, but all truth of the first invalid guys is equal to, hang on, other way around, of the last invalid guys is equal to 1. Right, those are the ones that are true samples as opposed to fake samples. And then I don't want to train on batch, I want to, well, I want to fit, question, quote unquote. I want to fit on all data, comma, all truth here. And what I want to do is I don't want to fit it all. Split equals 1. I want all of the data used for validation. Validation split. Fraction of the training data to be used as validation. Yeah. Blah, 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 blah. So yes, all of it. is what I want. So don't do any actual training. Just validate. And that'll happen every epic. So I already created that. Let me try this and just see if this blows up in my face or not. I don't really need that there anymore. That's just printing things that I don't need to print. What I can do is change this to TQDM. Just so that's a little less crazy. Let me try this. Just so we know where we're at. There we go, okay. So we can see we got about 30 seconds. It was probably almost done before. This is going to be considerably less crazy. Again, this is just going through one epic, so it's going to do all this nonsense. This little progress bar will finish. We'll move on to the next bit where we test the validity. And then we should be able to see how it's doing. So yeah, about 40 seconds total, which feels like forever, but is not the end of the universe. Okay, and it crashed and burned. That's fine. That's totally fine. All the input array dimensions for the concatenation, much matches down, leave a long dimension one. Okay. One hot data dot shape. Gen data dot shape. Oh. Oh my. I did not think that's what gen data looked like. What? What? That's not what I wanted. Oh, no. I see. Not gan.predict. No, my friend. Generator.predict. That's what we want. Now it's the right shape. Good. Do this. Do this. Do this. You should be able to see this. And it's like, 100% accuracy. Probably getting 100% accuracy here. Because the GAN looks like... because the generated results look like hot garbage. That's my suspicion anyway. And in fact, if we look at, I don't know, gen data, and I want to plot that. Let's see, gen data.shape here. That doesn't look as hot garbage as I would have expected, actually. Not quite as terrible as I would have expected. Yeah, okay. That is interesting. These are a variety of values, some zeros, some... Tell you what, though. If I were to say, numpy.arg max, just hypothetically, of course, axis equals 2, which letter has the highest probability, so to speak? Yes, 12, and if we were to plot this, just, again, hypothetically speaking, plot that p-color mesh. What does that look like? Yeah. So across all of them, this is the most common letter in every category, and in fact, I bet we could take the mean down that axis. Axis equals 0. And then we can look at that and say plot dot p-color mesh of that. Precisely. Yes. So this is which letter is popular. This is which position. In fact, I should do this not with p-color mesh, but like mat show or something. Mat show. There we go. So this 0 is at the top. Yes. 12, this other letter. I do not know why that is. What is 12? Do I have like a letters thing somewhere? I'm sure I do. Sure, it's somewhere. Lowers? That's not exactly it, but it is basically. M is about real popular these days. I see. So this is the problem that we have. that it is way too easy because the generator is absolutely horrendous. I don't know why it's so bad. Like, this is a mystery to me. Generator dot, I don't know, get weights. Yeah, let's take a look here. What is terrible about this generator? How many weights do we got? Okay, W0. What does this look like? 518. Yeah, whatever. Plot dot make show of W0. All of them, 0, all of them. So it's really only a 5x8 thing, so we can get away with this. I don't know, these look not crazy. Those are some big ones. I don't know, that's fine. What's W1? You know, pretty reasonable looking. Show me W2. W2.shape is going to be a little bit goofy here. Right, these are the 5x5 windows, and this is the space over which it occurs. It takes 8 inputs, 8 channels, and it's... Is that right? Should this be 5x5? Hang on. Oh, it's a one-dimensional. Yeah. So it's not 5x5, it's a 5-long window. Yeah. 8 inputs. Maybe the ReLU, maybe the max pool. No, the max pool's fine. The max pool's gotta be fine. Maybe my learning rate is way too high on all these. That is a possibility. This sets learning rate for the GAN. Where is the learning rate set for the discriminator? That is interesting. The discriminator, as far as I'm able to see, where is it? It's up here somewhere. Yeah, I mean, it's super small. Let's change this. Oh, that actually looked okay, right? Yeah. So, let's change it down here. We got way more weights. Let's change this. From that to, like, I don't know, 1E -7 or something. Something real small. Let me reset. No, discriminator can actually stay. Discriminator's garbage. It's fine. It's fine. Retrain it. Let it go for another epic. It's like, I wanted to do something, right? I don't want it to just be stuck there. And again, this is about 40 seconds to go through an epic, which, you know, takes a little bit of time. I'm only doing about 18, 19 iterations per second. Each iteration being 32 names long. So you want to take 18 times 32 to figure out exactly how many we're really doing. Which is like 2 to the 4, 2 to the 5, 2 to the 9, like 500. Maybe 550. Yeah, 530. Or so. Names a second, which really ought to be faster. That's really not that many. Okay. Ding. Yeah, it says, oh, it's perfect. Yeah, well, I'm not so sure. DanDoesData. We're gonna recreate DanDoesData just to be paranoid. DanDoesData. Okay, same thing. We're gonna plot the same nonsense here. And I get the exact same output. This is wild. Why is this generator this way? Is it because the discriminator was that way? Let me redo the discriminator. Let me redo the generator and the discriminator, actually. Ha 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 ha. It could be related to the encoder as well, that it tends to encode things to that letter for some reason. I'd have to look into that, get a better understanding of what the heck's going on. Skip all that nonsense. Here we go. Get the GAN. Do that. Okay, do this. And we'll do it down here. And we'll put our plot command in the code. Review the generator. Right, because the generator is producing garbage, then I am frankly suspicious about how good it actually is. Because if the discriminator is perfect, well, that's great. I guess you could also train the discriminator by like literally giving it garbage, just randomly generating data yourself. Not with the generator, but just with a dumber process. Just to see like, well, how well does it really do? Just to keep it on its toes. I mean, is it? Oh, not perfect. Okay, that's better. Frankly, I'm happy about that. Okay, this is an improvement. Right? You see certain letters tend to be very, very popular, and at the end it all changes. It really ought to be like really popular for a certain letter at the end. But it's at least not all one thing. That's what I was concerned about. So let's do that. Let me look at some of this generated data. And then let me write a dumb function of, I don't know, space to, make word. Make name, whatever you go. Whatever your input data is. Make names? No, just make one name. I don't want to say 4D in data. No. You can do this as a little list comprehension here. Where are my actual 28 long? It's not whatever dot lowers. Is it DD? No. Is it allowed? I mean, in a sense, it is allowed. Chars. There we go. That's what it's called. Chars. Okay. So, chars. D is which position I'm looking at. Argmax D. So, plot the index with the largest value. And join these together. And we'll just return that. Return. See if I can spell. That would help. And so if I just say make name of gen data 0, for example. Let's see what we get here. Lots of J's and S's, and the occasional R's and ES's at the end. Okay. Sure. And if I do this for the first, I don't know, 10 of these groupers, for G and gen data, first 10, you know, there is a very mild amount of distinction here. But the discriminator just seems to be so much more powerful at this point. I guess it has a much, much more easy task to do. So maybe we should do a ton more GAN training than we do discriminator training. That's an interesting idea. I kind of like that idea. Because like the discriminator just has such an easier job. It's like, yeah, just count, just count, just count. Let me do one more epic. Just to see if it does any different there. If it doesn't, I will try training the GAN more vociferously. And again, I don't really need this start-stop nonsense anymore. Yes, and the GAN, I give the GAN credit when it tricks the discriminator. That's why it's 1 minus fake out. And if that seems to be screwing me, then I will invert that process and say, nope. Yeah, that's another thing to try, but I really feel like that's the right thing. 9998. Okay. Again, not perfect, but that's fine. I feel like I'm seeing more variety. Just look at some P's and stuff. Let me do this. I don't know. Maybe it's more, maybe it's not. I do think we should train the GAN part of this equation considerably more. I do think that's the only fair thing to do. So, let me see here. How to do. It's 4i in range, I don't know, 10. Train it, twice as much. Yeah, I mean, that's fair, because it gets to train on the true stuff and the false stuff. So it gets 2 sets of training here. I think that's fair. And so this will take 50% longer to train these now. Yeah, from 30 seconds to about 50 seconds. And then checks out. Maybe it was 38 seconds, however long it is. But I think we're going to be about done with this after today. I'm getting tired of it. We've reached the stage of like the model is built, but we need to tweak a lot of things, and that's just not as exciting to do on stream. I imagine it's not as exciting to watch. There's just a lot of staring at it. Okay, what's wrong with this part? What's wrong with that part? What can I tweak here to make it a little bit better? Can I tweak there to make it a little bit better? Putting together the system, I feel like is getting started is always very challenging. So this is a way to do that. If you have thoughts on what I should work on next, I will be very open. I don't know if I'll get around to a stream next week. We'll see. I'm still moving a lot of things. I got a couple of different ideas on what to do still. Loss is this, accuracy is this. Okay. Yeah, this I don't know. Man. I'm not super convinced here by this. Why is DanDoesData? Why is it that way? Here's a silly thing. Generator.predict. I'm gonna throw in a bunch of zeros. Okay. What kind of space do I expect? What is fake data shape? Okay, so that's the right shape. Yeah, generator.predict. I just want to know. I throw in 256 random numbers. Oh, hang on, not 0, 1. That are all, sorry, not random numbers, zeros. What do I get? Right? I mean, that's the thing that like. This is just sort of like the flat bias. What are we getting? See, that's actually very different. If I do make name z of 0, get a whole bunch of new lines and an L. Curiously, so that's very, very different from what I'm getting. I wonder if how distinct is my fake data? Maybe that's part of the equation. Like, are these all very, very similar? Fake data.shape. Yeah. So let me do plot.makeShow of fake data, everything, and obviously the first channel, because there really aren't any channels. Yeah. So this space is just very, very uninteresting. Okay, it's every couple here, it's like every eighth is mildly interesting. It's like maybe the space is actually too large, frankly. And we want to make it smaller. I think about the right way to do this. That's the discriminator, that's not what I want. Just the generator. So this is 256 because why? I remember rigging it that way, but output shape. Well, because the encoder is that size is one reason. Input shape equals n length times 2, comma 1. Really? What is n length? 16. Not sure what's going on here. The output shape is 256. What is generator dot input shape? 256 comma 1. That's just curious. I create 8 input channels with a 5 long convolutional window. I'm saying my input shape is n length times 2. N length is 16. How does this even work? Right? I mean, you do this, you do this. 256 times 1. Oh, n length squared. Duh. That's the size. How did I arrive at that conclusion that it should be n length squared? What? That doesn't make any sense. I don't know how I came to that conclusion. I think I decided at 256, not n-length squared. I'm sure I can go back and watch the video and see like, oh yeah, I'm going to make this n-length squared. That makes sense. It certainly doesn't have to be that way, though. For example, we could get rid of 2 of these layers in the encoder, right? Let's get rid of this, get rid of this, boom. Now we take the encoder, redo that, encoder dot output shape. Now it's outputting 64 numbers. Interesting, interesting. I'm not even sure we want to go, we might even want to go nuttier than that, but I think I'll settle for that right now. And that means that we need to nuke a similar number of things here. This one, this one, this one, this one, this one, this one. Okay. And not n-length squared. I don't know how I came up with that. That's just not true at all. 64. Okay. Let's do this. Let's grab the encoder too, redo that. Yeah, we'll do all this stuff. Refit the encoder. Should be fine. We'll let the generator stay whatever it is. The accuracy's not terrible here. I mean, it's not great, but that's fine. It doesn't have to be spot on. In fact, if it is, I'm suspicious. Okay. Give that a few more seconds here. We'll have to remake our discriminator, of course. I mean, we don't have to, actually. But it's learned some really bad things, so I think we should. Remake the discriminator. I'm going to let it have the same number of inputs, because why the heck not? It's just trying to predict one thing. Or is it already, like, way too strong? Interesting quandary, interesting quandary. But yeah, so much of my space was unused. Really, I was only using like 1/8 of the space, so maybe I should have even said I only need 32 numbers, but we'll see. We're only halfway through this, so we got plenty of time to screw around and figure this out. I do need to redo this. Remake my latent space here. Right, that's all that nonsense. Latent.shape. And so what I want to do is look at that. Probably we can just look at the means, I guess. Nah. I like to look at the actual thing when I can. Latent of all the things, kind of the first channel. Yeah, that's really helpful there. Yeah. Well, I'll tell you what. Let me just, rather than mate show, we're just going to plot. And rather than do that, we're going to take numpy.mean along the first axis. There we go. Yeah, still this, like, every nth thing is the only one that matters. X equals 3, x equals, what, 6 or 7? 3.5 now. This is just really peculiar to me. 11. 7, 11, that's 4. Oh, so it's like 3, 4, 3, 4, 3, 4, 3, 4. Probably what it is. Interesting. Okay, what is 64 divided by 3.5? 18. Interesting. Very interesting to me. That is most curious. You know what? I am very tempted to continue to cut it down here. But I want to see what this does first. Let me grab this discriminator, which I think I already grabbed, but whatever. Do this nonsense, yada, 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 yada. Need this. Don't need that stuff. I've already defined how my GAN works. Get a new one. And yeah, let me train here for a hot minute. It should be a little bit faster. Oh, hang on. There was an error here. What happened? Model instructions with blah 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 was recalled and has everything compatible blah 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 blah. Okay. What is Velio? Oh, fake data has the wrong shape now. Right. That shouldn't be a problem with this object. Oh, okay. This needs to be 64. Not recording. There we go. Right. Another thing to sort out. Okay. 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 See how this goes. And again, this should be faster, but it seems like it's a little bit... Yeah, okay. It was like 50 seconds, now it's going to be like 38. About 10% faster, as you can see my number of iterations, because the model is just smaller. So that's good. Oh boy, oh boy, oh boy. We'll see how it actually does here in a second. Again, if that discriminator is perfect, I'm highly suspicious, but I want to see what does the generator output actually look like. You know what I really should do? I should take this, move it up here, ooh, move it up here, grab this, and I just print this. Just print this list, because I want to know. You know, show some gen output. Yeah. Accuracy 100%. That's suspicious. Okay, almost all new lines. A couple C's. Oddly enough, I think that's less bad. There are an awful lot of new lines, because there's a new line at the end of everything. So I'm actually slightly less concerned about that, if you can imagine. All these small values, this is like 40%, 60%, 67. That was only 10%. Oh, because that's a different position. Right. 62. Yeah, so it's not always that. But it is very often that. Couple C. Yeah, the C is very strange. I'm inclined to let this run for a little bit while we try to understand what the heck is going on. Give that a go there. That's not what I want to show. Here we go. Also, I found this cool thing. TensorFlow, the actual team at Google, they released a special GAN module, Python module, I guess you could say, for doing typical GAN things. So I thought that was really, really neat. I don't know if they have examples. Oh, they do have examples. That's really cool. Cypher, Colab notebooks, progressive, self-attention. I don't know what these things are. Star GAN? Like, what is that? Debugging. Oh, they talk about it. Cool. Oh, yeah, what's Star GAN? Multi-domain image translation. Some more Cypher stuff. Self-attention. I haven't looked at that. That'd be interesting. Cycle GAN. Image-to-image translation. Nah. Cypher 10. This is like pretty straightforward. Not Cypher. We use the inception score. I'm actually kind of curious. And you know, the standard M this thing, which maybe I should have done. You know, maybe that would have been a smart idea to just do that first. Let's take a look at their example. Oh my goodness. This is your MNIST example, and you got a million things in here? Okay. I don't think this is quite what you wanted. Unconditional, conditional, info GAN. This one, this one, this one, I'm guessing? That's what I think you mean. Train.py, conditional, unconditional. Unconditional down here? No, conditional's up here. Let's just check out train, see what it says. Might be relevant. Use generator and MNIST data. No it doesn't. This just calls trainlib.hparams. Okay, trainlib. Named tuple. Isn't that just a dictionary, buddy? Oh, but it's a tuple, cannot change. Okay, okay. Learning rates, kind of small. Needs an MNIST GAN. Generator.networks.unconditional generator. Oh, I can just click this. Yeah, take me there. I like this. This is a nice feature of GitHub these days. Use a generator to produce unconditional MNIST images. Generator helper. Okay, let's go there. Okay, this is the actual object. Functions reuse different GAN modes. Okay. Looks like you do some kind of dense layer. 1024 noise, like garbage input essentially. Some weight decay, take a batch norm, do some ReLU stuff. If it's conditional, you do some special thing. Dense, batch norm, ReLU, then you start deconv. Okay, but this is real weird, the way this is defined. Oh, no, that makes sense. That makes sense. From a dense thing, generate some stuff, reshape it into the shape you kind of want, do some deconvolutions to get a thing that you sort of want. And then tanh. You know, -1 to +1. Sure. Okay, that's all the generator stuff. Where is your discriminator? Func tools at partial info gain discriminator. Detail discriminator helper. Okay, core MNIST discriminator. Take a convolution, leaky ReLU, convolution, leaky ReLU, flatten it off, do one set of dents, and then smack your output out. I'm sorry, you have dense 1024? What? Oh, maybe there's some special. Oh, okay, yeah. At this point, this is a network. You can say, well, how many things do I need to predict? If I'm predicting a whole bunch of different classes, which in MNIST you are. Well, sort of. In the MNIST GAN world, you're just trying to say, is this real or false? Real or fake? I am not seeing improved results here. Still seeing like the occasional C. 2 C's, you know, that's marginal improvement there. I don't know why that's such garbage. That's curious. Is it because the learning rate is like too high, too low? Nobody knows. Like we can interrupt that there. Let me make a new GAN. Just do that there. And hope that I'm not too far in a corner already. You might be. And we'll just see, how does it do? Oh, with this smaller, larger learning rate. Because maybe it's just way too much discriminator, but the generator's not going hardly anywhere, which is really irritating. It's like, why is the generator such garbage? Maybe I should look at the last layers of the weights in the generator. I'll let it finish this iteration here. I only got a few more seconds. 7, 6, so on and so forth. Yeah, it's a bit frustrating. Just like getting it to do something. Yeah, oh, we're getting IIs now. That's different. They're all the same, which I suspect is... Yeah, okay, II, and then all this other nonsense. Not surprising. Let's do that there. Yeah, I mean, that's fine. That's totally fine there. But it changed, I guess. That's something, right? Eh. It did something, that's true. I can make a stupid simple generator, I guess. But like, make a simple linear. That's really what I should have done first. Just to see, is this doing the right thing? The discriminator shouldn't be allowed. I don't think it's getting allowed to train right there at all. Accuracy. Why is validation not? That's curious. Discrim.fits. That is odd. Is the loss always the same? No. That's wrong. You should not be getting to do anything. Validation split 0? I mean, what's the deal here? Validation split, 0.9999? Yeah, that's what I thought. You get to train on like one guy. Okay, so validation split 1 is just not respected. How many 9s can I add here? Is this still gonna work? Can I convert float infinity to integer? Buddy, there's no. I see the problem. I see the problem. Yeah, that's what I thought. It won't actually do that. Scrim dot. Oh gosh, I want to like validate. But it's like if I do predict and I got to do this stuff myself, it's just a huge pain in the butt. Oh, predict classes maybe. Generate class predictions for input samples. Input samples are processed batch by batch. Right. So I think that's probably what we really want to do. Predict classes. Let's see this. Okay. In all truth. Yeah, okay. This. Save that off. What is this nonsense? Redonkulous. Okay. So I want to print numpy.sum of this equal. Can I actually say that? Can I say equals? Is this gonna work or is it gonna yell at me? What in the garbage? Okay, I gotta reshape some stuff then. So let me. This is our prediction. Grab this. It goes there. That just gets flattened. Oh, in fact, I can just say flatten. Equals all truths. All truth. There we go. Divided by 2 times invalid. And this will tell us our accuracy. Not pred, but ants. Ants. There we go. Ding. Okay, perfect. And now it's not going to do any training, of course. Okay. That's good. But, like, why such hot garbage? Well, let's ask the internet. Machine learning, or, you know, like Keras, TensorFlow, whatever. TensorFlow, GAN, like generator stuck, generator bad, generator poor, maybe. It must include poor. Weak. It's like I want to, like, how do I fix this? How do I fix my generator? Or is it somehow learning to be as good as possible? All right, you know what, that's time to make a new generator, because that one is hot garbage. New discriminator, too. New discriminator. New generator. Yeah, I should have to sample from this area. Or do I sample? Yeah, I suppose that's fine. What? What are you doing here? There we go. Yeah, I'll keep the same input area. The same latent data, so to speak. Just cuz. Get a new GAN. And let's see, I'm gonna run that while I think about this. Like, why is the generator so bad? Maybe what I should do also is make like a super dumb linear generator. Just absolute, almost as dumb as you can get. Take the latent space, those 64 numbers. Yeah. And what I want to do, come up here and grab the first couple of lines of my actual generator to make sure I get this the same. Yeah, there we go. Just that. Those are slightly different. Slightly. Let's grab this. Yes, okay. I don't want to do a convolutional thing at all, even. I do need to accept that input shape. But what I want is actually like a reshape layer. Is that a thing I have? No, but I think I have flatten. Really? I don't have flatten? You gotta be kidding me. Dense? Alright, yeah, let's just do dense. Fine, we'll do a dense. I do this somewhere here, don't I? Now the generator takes flat input, essentially flat input, and computes a non-flat thing. It loves vowels. I mean, vowels are more common, so I think that's interesting, right? Right, that's decent. More common letters are showing up more often. That's good news, I think. I don't know. This number's still, you know, way too high. Oh, now it loves T's. T's and spaces. Okay, that's interesting. It seems to always get like one wrong here, which is weird. Maybe there's one that's just like empty or something. All new lines, and so it looks like garbage. Right, I need to take dense input, what is essentially dense input, and turn it into a thing. Right, because at the end I need to have the correct size output, 16 by 28. All right. Now I'm producing all spaces. Great. That's great. That's super good. You know, progress, right? Progress. The space has got to be really common. One of these days. One of these days. All right, let me think about this. Should not the generator have deconv? Is that my problem? I'm doing convolution and not really deconvolution. What's the encoder do? The encoder does conv 1D transpose. I think I may have gotten these things mixed up. Yeah, I think that might be the situation here. Shouldn't really make a difference. Alright, this seems to be pretty well stuck. Yeah, that's really interesting there. Generator. That's summary. That's summary. Yeah, that's. You're done. You're done. I think that might be part of my problem. Like, what I really want is a deconvolution. I don't know why I didn't have that. Conv 2D transpose. Yes, that's exactly what I need. Why? Apparently I've done this all zip-zod doodah backwards here. I mean, the shape is nominally correct, right? But I don't think that's really what I wanted. I don't, like, why am I max pooling? I need to be expanding my space. Oh, like here. Oh, I'm shrinking one space and growing in the other. That's what I'm doing. I don't know if this is really the problem. But it's entirely possible that it's a problem. And I don't know why. I have one channel there when I really should just be able to get by on. You know what? Change this to like 16 numbers, right? I'm gonna fix this in the next, 5 minutes. End space, I don't know. 16. This will be end space. End space. Cool. We're making a new model here. End space is not defined. Well, I'll define it then. Generator.summary. Model has not yet been built. Yeah, well, fair enough. Can I do this? Slayer has never been called. You bastard. Alright. They just do con 2D transposes to do things. Sometimes with stride 1-1, sometimes with stride 2-2. Well, they're doing 2D transposes. My con 1D transpose, strides equals 2. I could double in things in size. Which isn't exactly what I want to do. I'm making a 16 long thing. So actually, you know what I want to do? I'm going to make this 4. 4 numbers is all we're going to generate. Hopefully that's sufficiently interesting. Conv 1D transpose. Hang on. How do I use this? I will turn 4 numbers into... I want 16 by 28 numbers, right? Yes, that is what I want. So at some point I do need like a 2D. Well, no, I'll just have that many channels, I guess. I'll expand twice, I suppose. Yeah, we can probably do that. Let me see if this even makes any sense what I'm thinking about here. Strides equals 2, right? Strides equals 2. So expand. Activation rel U. I don't need this max pool nonsense anymore. Let me try this here. And see if this even makes sense. 16. Right? No, I'm expanding, so I don't actually need more things here. Yeah, it should be. This is their generator, right? Yeah. This makes the generator model. It should give you hot garbage. Okay, okay. Yeah, so this should honestly make that a little smaller, in fact. I don't need that. I do want this. I don't need input shape anymore. Get rid of that. What? Let me kill this there. Yeah, I don't want the 1. I don't understand why I would do that. I'm probably to drive myself insane. 4, and then we'll produce 28 output channels. Do they do... Hang on. Hang on a second. Hang on a second. In here... What I want to do is the same thing still. Transpose. 28, but we'll just do like a 1. We'll do a 5 of 5, sure. But now we'll say strides equals 1. Right, we're not gonna muck around with this shape, really. Oh, I see what I've done now. You need that. You need that. There we go. Alright, is this a thing that even makes sense? Well, if I could spell, it would be. There we go. Okay. 2 minutes. 2 minutes. We gotta shark around with this encoder a bit here. It will no longer have conv1d transposes. That doesn't make any sense at all. It should just have conv1d. And there was never any reason, and max pooling, right? Or whatever. I don't know why I was doing it in this insane way. I don't think that's actually why it's totally broken, but I'm sure that's not helping. So this takes input of n length. Yes, that's true. Hang on. Comma 1. Oh, I see. This takes the sparse input in. Right, sparse categorical. That's why it's like that. Okay. I just need to get down to 4 numbers. Whatever I do in the end. Whatever this nonsense is. Like, this is all fine. Sure. Sure. Do this thing. 4, 8, whatever. Do these things. Absolutely do these things. Not transpose, though. I'd like to get this doing something, so we may run a little long today. That's okay. That's how it happens. Then I want 4. I just want dense. I want to flatten, I think. Encoder.add flatten. And then I think encoder.add activation. Dense 4. And I don't even want an activation. I just like do some stuff. You know, give me the linear output there. Flatten should be in keras.layers, right? Is keras the thing I just have? No. Do you have to keras.layers dot flatten? Perfect. Cool. Grab that. Okay, we got that now. Got our generator. Got this. Yes, so I'll spit out 4 numbers. That's fine. I will accept those 4 numbers. Excuse me, not 4, but n space. However big it is. N space. This should do a sensible thing now. do our generator. Okay. Let's do the encoder. A little. Right, and then let's do this model business here. Oh, wasn't happy about that. Why not? Input layer, sure. Encoder doesn't like this. Incompatible there, so I did mdim4, found mdim3. Really? Full shape received, none for 1. Why is it none for 1? Why? This is dumb. Real dumb, man. It does says no defined input shape. Yeah, except, you know, I defined the input shape. Yeah. Yep. What if I said none, comma that? Would that change how you feel about it? That thing we can do? Can I do this now? No. Full shape received. Yeah, see, that doesn't make sense. And that's clearly why I had this as a 1. And, like, that means I can't just do... Well, maybe I can still get away with this. Let's find out. Be awful strange, though, I think. To have this not actually be as dense like it's claiming. Yeah, see, it's lying to me. Expected end of 4, found end of 3. Full shape received, none for 1. Okay, tell you what, just do this, because I want to look at this model. Model's not yet, I just called compile on it. That just happened. Calling build or fit. Okay, bye. Do your jam. Great. I don't give a shit. I want to see the summary. Oh, you're full of shit. Just show me the summary. Of course. Of course. Show me the summary. There we go. You see 4 right there. Must provide an input shape argument. Input shape equals 4. dim2, not in the intervals. Uncommon 4? Is that what you want? Full shape received. None for 1. Oh, the transpose can't handle that. I see. That's why I was doing this. Now I understand a little better. Now it's like I make pain here or I make pain here. Okay. Alright, I think that's all I'm going to fight with. That might be the issue here. That this should have been transposes and this should have been convolutions. But we don't know yet. I've been fighting with this for long enough. I think I'm ready to move on. I might futz with it a little bit more, but not on stream. I think we understand the concept of GANs, even if their output was, you know, hot garbage. Maybe I should have gone through an MES tutorial. Maybe that's what I'll do next week. I'll walk through a tutorial by another group just to see, like, all right, what's happening here? How could I adapt this? Those kind of things. All right, that is all for this week. Hope you all had a good time. Hope you all learned a lot. I'll be back next week. Don't forget, stay safe in the data mines.